So this video accompanies the organizer that is on page 505, entitled Characteristics of Types of Reactions. What we're really going to take a look at with this organizer is the kind of clues that you want to look for to figure out what kind of reaction you're looking at. And then we're going to see several different reactions for fun. But if you take a look, what kinds of things you want to look for is how many reactants and products there are. Is there just one reactant? Are there two reactants? And same idea on the product side. And then what kind of substances are they? Are they ionics? Are they elements? Are they molecular? That's what that's what's going to help you identify what kind of reaction is going on. So for each one of these reactions, there is an example that I've got the video for you to take a look at. But before we do that, we'll take a look at what kinds of characteristics you want to be aware of to identify that that's actually that kind of reaction. So first up, we have a double replacement reaction. It involves all ionic substances. So two ionic substances on the reactant side, two ionic substances on the product side. And so really what you're seeing is you're seeing partners switch. So if you look at the example in your organizer, cobalt chloride and sodium phosphate are the two reactants. They're going to switch partners. Cobalt is going to go with phosphate and sodium is going to go with chloride. So here is that reaction.
Well, yep. That's the stretches.
I'm not touching.
So you can see from that reaction, you've gotten a precipitate formed, a solid formed, that was purple in color when you started off with something that was pink and something that was colorless. So that was kind of fun. Oops. Next reaction that we're going to take a look at are single replacement reactions. Now here, once again, you have two reactants and two products, but the characteristics of those substances are a little bit different. You have one thing that's ionic and one thing that's an element on the reactant side, and then likewise on the product side. So in single replacement, you have just the substitution of one of either the cation or the anion. So for example, the reaction that we're going to take a look at is magnesium, which is our element, a metal, reacting with HCl, which represents our ionic substance. And what's going to happen is magnesium is going to replace the cation in the ionic substance. So magnesium also becomes a cation, so you see it replacing hydrogen. So hydrogen comes out, magnesium goes in. So that's a single replacement reaction. And so here you've got, sorry. Here you've got this one.
In the single displacement reaction of a metal with an acid, we will react magnesium metal with hydrochloric acid. As we add the magnesium metal, we get a very rapid reaction. Hydrogen gas is produced by the single displacement reaction. The metal reacts completely, leaving us the solution of magnesium chloride. We can test for the presence of the hydrogen gas by bringing in a burning splint. The hydrogen gas is flammable and ignites.
That's fun, a little bit of an explosion. So then single and double replacement both involve some ionic compounds. You have them switching partners basically. So can you tell the difference? Two and two reactants and products, but the identity of them are a little bit different. So if we move on to the third type of reaction, that is, whoops, I did them in the wrong order. We're looking at decomposition first. So a decomposition reaction involves one reactant, which is going to be a compound, splitting up. It's decomposing. It's breaking apart into at least two, maybe more products. And the types of substances that are products could be anything. Elements, ionic, molecular. It really depends on what the starting material is. So we're going to do something pretty simple, but a lot of fun. You've probably seen this demo before. We're going to decompose hydrogen peroxide. We're going to decompose it into water and oxygen gas. So let's take a look. So that's fun. So that's decomposition. One reactant breaking apart into multiple products of some sort of characteristic. Okay, so moving on to the fourth type is synthesis. Now it's only listed third as you on your organizer, but synthesis is the fourth kind of reaction. So kind of the opposite of decomposition. We're creating one product from multiple reactants. So again, the reactants could be anything, elements, molecules, compounds, but you wind up with just one product. So here is the reaction of magnesium with oxygen.
Group 2 metals also react rapidly with oxygen in the air when they're heated. Magnesium is flammable.
Bright light. So notice you get magnesium and oxygen gives you magnesium oxide. The magnesium metal was covered with white powder for that one to show you the magnesium oxide. Gosh darn it. And so then the fifth one, this is the last demo we're going to do. You'll probably like this one the best. Combustion is the most specific kind of reaction because of the needed nature of the products and reactants. So reactants, there's two of them, but they have to be something organic, something with carbon and hydrogen, and reacting with oxygen. So oxygen has to be a reactant. So something organic reacts with something with oxygen. And then the products are going to be, for us, we're just going to stick with carbon dioxide and water. Sometimes you get carbon monoxide, but we're not going to go there. So for us, carbon dioxide and water is what you have to have. So you don't have a choice. Here's an example of a reaction. We're going to take methanol, react it with oxygen, and we're going to produce CO2 and water, and actually you're going to get a whole lot of energy out of that as well. So here's a fun reaction.
We've not done the lights. Ready? Yep.
So what they did is they had methanol, which is a gas, inside the tube, obviously mixed with the oxygen in the air. When they lit it, you got to see a nice fun explosion and producing CO2 and water. All right, the last thing on the list is something called a redox reaction. Redox reactions encompass a lot of the other types of reactions that you saw. It really depends on the movement of electrons. So redox stands for oxidation reduction reactions. And a redox reaction is always going to involve the movement of electrons. So you're going to have charges change from the reactant side to the product side. So here's an example. We take magnesium and react it with silver nitrate. You get magnesium nitrate and silver. So can you identify what kind of reaction that is in addition to redox? Hopefully you've seen that it is actually a single replacement reaction. You have an element reacting with an ionic substance, and the element is substituting itself in for one of those ions in the ionic compound. In this case, magnesium is substituting in for silver. So what's going on? On the reactant side, magnesium is a metal, so it's got a charge of 0. But silver has a charge of +1 because it's in an ionic compound. On the product side, magnesium is now in the ionic compound, so it's the thing that has to have the charge. Magnesium has a charge of 2+. On the product side, now you have silver, and I realize this equation is not balanced. I should have a 2 here. You have silver metal, which now has a charge of 0. So magnesium lost electrons, silver ion gained electrons to become neutral, and that's how you have a redox reaction. The electrons moved from magnesium metal to silver ion, creating neutral silver atoms and magnesium ions. So that's an example of a redox reaction. So use the organizer to help you start to identify different kinds of reactions.